Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here are another problems on the interpretation of the derivative and sketching the graph of the derivative of the given function. I hope that this video will help you improve your thinking skills in mathematics, which is important in your preparations to engineering life. So trace or copy the graph of the given function f. Assume that the axes have equal scales. Sketch the graph of f prime below it. So this is the given graph. So if we draw the tangent here is from the left is almost horizontal. So when the tangent is almost horizontal but of positive slope, the value of f prime, which will be the ordinate in the graph of f prime, is almost zero but positive. Then it is increasing positively until it becomes infinite here, or the slope is undefined. So therefore, because the slope is undefined here, f prime is undefined or infinity, it means that the line x equals 0, or the y-axis, is a point or a line of or a point of discontinuity. X equals 0 is a point of discontinuity. Then for the just to the right of the y-axis, the slope is, it begins with undefined slope, so we have a point of discontinuity at the origin. Then the slope is, it starts with positive, which is very high, so positive infinity, and it decreases until such time that it is again almost zero, horizontal here. So f prime is almost zero, but that slope is still positive. So therefore, if we sketch the graph of f prime, so we project it downward, then this would be the graph, expected graph. The slope here is almost zero but positive, so the ordinate of f prime would be almost zero but above the x-axis, still above the x-axis. The ordinate, or the slope of the tangent here, increases until it becomes infinite here, or almost vertical. So that means the slope or the ordinate increases until it is infinity just to the left of the y-axis. Then just to the right of the y-axis from the graph of f, it begins with positive infinity, and the slope in this original graph but ordinate on the graph of f prime is decreasing until such time that, so the ordinate is decreasing, so that's why the y coordinate is decreasing until such time that it is again almost horizontal here, so the slope is almost zero but still positive or above the x-axis. So the graph of f prime therefore is this. So I hope that you understood that explanation, and you grasp the meaning of the slope of tangents in the original graph, then ordinates in the graph of f prime. Next problem, make a careful sketch of the graph of f, and below it sketch the graph of f prime. Can you guess a formula for f prime x from its graph? So for part A, f of x is sine x, and it is given. That's the graph of sine x. So we begin with the tangent here. Just to the left, the tangent is almost zero but positive, so it is above the x-axis because the slope of the tangents in the original graph are interpreted as y coordinate in the graph of f prime. So except here it is 0 at negative 3 pi over 2, so it crosses 0 here. Then the slope is negative and it increases until maximum here, because this is the point where the slope increases and it stopped increasing, and it is now decreasing here, but negative. So meaning to say the ordinate would be negative. It is increasing until such time at this point negative pi it is maximum but negative. Then negative slope, negative 1 for example, definitely that's negative 1. Then below it, so negative 1, the ordinate is negative 1, then it is negative, the negative sign decreases, so the ordinate decreases, the y coordinate decreases negatively until such time that the tangent here is 0, so that means the ordinate here is 0, or it crosses the x-axis. Then from 0, the slope again is increasing positively up to this point. This is the maximum point, and the point here is, the slope here is approximated as 1 based on the figure, but that's really the slope. So that means it crosses 1.0 here, and next is the ordinate is 1.0. Next is from 1 it decreases, so let's say 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.3, 0.2, until it is 0 again here. So the graph crosses here, so from 1, 0.9, 0.8, 0.7, 0.6, 0.5, 0.4 up to 0 here. Then 0, we have it increases negatively again, negative 0.2, 0.4, negative 0.6, negative 0.8, then negative 1.0. At this point the slope is negative, so negative 1 ordinate here. Then we just copy this part because it's the same as that. So copying the graph of f prime for this part, which is this part here, we just copy. So that's it. That's the graph of f prime. And for those who already know, since I already discussed derivative of trigonometric functions, just the basic ones, the fact that this is, if you are experienced with the graph of cosine, this is the graph of cosine x. Therefore, f prime of x is cosine of x. So for the second part, make a careful sketch of the graph of f, and below it sketch the graph of, this time, f of x equals e to the x. So the graph of f of x equals e to the x is this. So beginning with the left part, the tangent is almost horizontal, but it is still positive. So the ordinate, remember that slope of the tangents here interpreted for the graph of f prime would be the ordinate or the y coordinate. So it begins with almost 0 but still positive, at it increases until at x equals 0 the slope is approximated at 1, f prime equals 1. So the graph of f prime will also cross x equals 0 and y is 1, and the slope increases until such time that it is almost infinite. So just like this, the ordinate will increase from 1, 1 point something, then 2, 3, 4, 5, and so on and so forth until it is like that infinite. So therefore, the graphs seem to be the same. And in fact, later on, if you know the derivative of e of x exponential, which I have not yet introduced, is the same e to the x. So therefore, the graph would be the same, even if we just base it on the estimates of the slopes here and estimates of the ordinates or the y coordinates here. So with regards to the formula for f prime, we have to guess because the graphs look the same, so it is e to the x. Then finally, for f of x equals ln x, this is the graph of y equals f of x equals ln x, or y equals ln x. So it begins with a tangent which is positive infinity, almost vertical, but it is leaning to the right, so positive infinity. So for the ordinate, it begins with positive infinity for the graph of f prime also. Then it decreases until such time that the tangent here is, by approximation, is 1. So meaning, at this point directly below, it crosses y equals 1 point. So x is 1 and y is 1 because f prime is 1 there. Here, the y coordinate of f prime is 1. Then the slope from 1, it decreases. So let's say 0.8, 0.6, 0.5, 0.4. As x approaches infinity, it is almost horizontal but still positive. So that's why the ordinate here is almost 0 but still positive. So from 1, 0.8, 0.6, 0.5, 0.4, 0.3, 0.2, then 0.1, 0.0, 5, 0.03, 0.02, and so on and so forth, almost 0. So this is the graph of f prime. And to guess its formula for f prime of x, because 1 over x is when x is almost 0 but just to the left, it is positive infinity, just like that. When x is 1, it is also 1. And when x approaches infinity, it is 1 over infinity, which is almost 0 but still positive. So this is the guess for the formula for f prime x for part C. So that's it for this video. I hope that your knowledge in calculus is enhanced.